One example of greedy algorithm is Prim's algorithm. It is an example of minimum spanning tree algorithm, wherein we consider the minimum value of the weight of the edges in creating the subgraph from a given graph. So usually it is used to determine the shortest path between 2 points in a connected weighted graph. So we could use it in creating a cabling system or a water pipe system that connects the source to your houses. So what are the steps in implementing prims? So first, we initialize the minimum spanning tree with a vertex chosen at a random. So it's up to you which vertex you're going to use as your first step. And then second, find all the edges that connect the tree to new vertices. So all the edges connected to the first vertices, consider it, find the minimum value to go to the other vertices. And keep repeating step 2 until all vertices will be part of that graph. And be sure there will be no closed loop when we choose the edges. Okay, so no closed loop. So let's have an example. So we have 6 vertices here, A, B, C, D, E, F, and we have different weights that connect these different vertices. So first step, choose among the 6 will be your first vertex for your analysis. So for me, I'm going to consider the C vertex. This is my first vertex to consider in my shortest path. And then I'm going to analyze which are the different edges connected to it. So we have 4, 3, 4, 2, 2. So based on step 2, consider the minimum edge on your connection to the next vertex. So I'm going to consider this 2. So it means I'm going to add B to my C. And then we have another edge that contains 2, which is this. So it means I'm going to include E through C. So now there are lots of vertices that is connected to B, C, E. So let's check which has a minimum value so that we know what will be the next vertex to be added. So the next weight is 3. So we have 3 here, 3 here, and another 3 here. So it's up to you which node or which vertex will be added. Will it be D or F? And how we're going to add it, it's up to you as long as there is no closed loop. Okay, so for me, I'm going to consider this 3 that connects F from E. Okay, and then we have 2 options for D. Connect it through C or connect it through F. But for me, I'm going to choose connect D through C. Now, we only have one vertex that is not included in our subgraph, which is A. So we're going to choose which path, through B or through C. It's up to you. But for me, I'm going to choose through C. So connect A through C. So that will be my, my minimum spanning tree. Okay, so this is the result of the Prim's algorithm. And for the time complexity, we have 2 types. If we're going to use binary heap or Fibonacci heap. So if you're using binary heap for your Prim's algorithm, so the big O notation is E log V, while if it's Fibonacci heap, big O, V plus E log V. So binary heap, Fibonacci heap will be discussed on module 2. So what's the difference between these two will be discussed in module 2. Okay? So that's it for Prim's algorithm. See you on the next video lecture.